Jolene. Okay, so please measure all the sides. You can do them in millimeters. It doesn't really matter. Everything is going to be approximate. Why? Why are we not able to get exact measurements here, ladies and gentlemen? Why won't the measurements be exact? Can you guarantee you are starting in the exact center of this circle at the exact same spot I am? No. No. Can you guarantee you are measuring to the exact same middle of this circle? No. No. So everything's going to be close, yeah? That's all I really care about. Okay? So we're going to call this 52 millimeters. Or, to remind us from last semester, or last unit, 5.2 centimeters. Everybody cool? So measure them all. I'm going to ask you for the angles because I don't have a protractor up here that isn't otherwise engaged. So, everybody, is everybody happy with those? Approximately, for the little guy. Yeah. Everyone's got somewhere around there?
We got slightly more or less by the unit.
Again, as long as you have something close, I'm happy because it's not going to get exact. What do you mean by slightly more or less in a unit?
Like for 5.2, we got 4.5. Same.
Oh, it's possible in the photocopy you guys have a different... Yeah. That's cool. Sorry, I should have done that. I should have asked you guys because the photocopying depends on how I printed it. So what did you guys have? Because we should use your measurements. You all had from C to B? 45 or 4.5 centimeters, great. And A to B? 9 straight up? 8.8, 9. I'm going to leave it as 9 because I'm lazy. And AC?
Yeah, can I get the keys? Thank you.
AC?
7.3.
7.3. All right, so everyone's cool with that. I'll just change these. 7, 9, and you had 4.5 here, right?
Yep.
Great. Now, what'd you have for angles?
97.
97 up top. B?
55.
55. A? Pardon me?
30.
30. Yeah, that'd probably be pretty close. This would, of course, have to be 95 in that case. But, again, it's not going to be exact. Why? Because what are we using? We're using a protractor and we're using our eyes, yeah? There's human error in all of these. Cool? Okay. Now do the same thing for the bottom. What'd you guys get for the big one? I need those measurements, please. F to D first, the big guy. 11.8. 11.8. And D to E? 6.8. 9. And F to E to F? 13.6. And what did you notice for the angles when you measured them?
Same.
They're all the same. So 95, 30, and 55. Everybody cool?
Yeah.
Okay. So this actually tells us a bunch of stuff that most of you already know, but I review it anyway because it's needed basic knowledge to understand and do trigonometry. So I like to go over. First thing we got to remember is a couple of things. One, labeling triangles. Okay? When we label triangles, we label them by the angles. Okay? So this is done by angles, and angles are uppercase. Okay? So this top triangle is triangle ABC. Is that cool? That is arbitrary. I choose where I start. I could have called it BCA. I could have called it ACB. Do you understand that? It is arbitrary. Once I choose it, that's how it's going to be. Okay? Now, the next triangle, somebody try to name this triangle. What is this triangle's name?
FDE, CBD, S. Oh wait.
Wow.
ED, F. FDE.
I went from the 30 to the 55 to the 95. So what's this guy's name?
FED.
F-E-D. Do not be fooled by alphabetical order. Okay? So the first guy is going to be angle ABC. Then you must follow the same order. So the next guy is triangle FED. Everybody cool? All right, that's the first thing. Next thing, angles, how they're named. That's how we label triangles. Labeling angles. We use the uppercase vertex. What's a vertex of an angle? Who remembers? Yeah, it's the corner. So in this angle, this triangle, triangle ABC, what is the value of angle C? 95. Is everybody cool with that? Okay. So angle C equals 95. Angle A equals 30. And angle B equals 55. That has to add up to what? 180. We remember that. And there's another way to write the names of angles. Angle C has two other names. What are they?
D. No.
Angle C in this triangle, you can name them two other ways. How would you name them, Noah?
CB and CA.
Not quite.
No.
But you're on the right track. ACB or Ranveer, I think it was you that said it? BCA. Please notice that the vertex is the thing that doesn't change. It's either in the middle or on its own. Is everybody cool with that? So what's angle A's other two names? CAB or BAC. And angle B is CBA or ABC. Is everyone cool with that? That's labeling triangles and labeling angles. Everyone is Gouda? Yeah. All right. Now, the next thing we're going to talk about is labeling sides of the triangle. Now, you already know the sides of the triangle have names, yes? What are those names? The ones we know, hypotenuse, leg, and leg, yeah? That's for 90-degree triangles. This 90-degree triangle? No. So we name it another way. We label the sides. Who knows this? Anyone?
Acute, obtuse.
Pardon me?
Is it like acute, obtuse?
No, that's the type of angles there. But that's a good answer, Jeswin. That's actually part of things as well. Yeah, that's one way to do it. The one way to label the sides is connecting vertices. So, up top I have AC. Now, since I'm using the vertices, I keep it uppercase. Is everyone okay with that?
Yeah.
That's one way to do it. The other way to do it, and I'm going to move down here for B, and this is the way you're going to see it on your provincial mostly, and the way I'm going to do it is you use the lowercase of the opposite angle. Now, what did I say yesterday or Thursday that opposite means for this entire unit? Across. Okay? So this side that is 9 has 3 names. One of them is AB. Cool? The other one is BA. Cool?
Yeah.
Yeah.
And the third one is Lil C. Got it? Because big C is across the way from it. Is everybody good with that? So what's this side? What are his 3 options?
AC.
AC, which would be capitalized.
CA.
CA, which would be capitalized.
Little tiny b.
Or Lil B. Everybody cool? And that makes this guy obviously CB, BC, or Lil A. Everybody good? Everybody can do that? Yeah.
Yep.
Okay, let's look at some other things that this tells us. What do we know about the hypotenuse?
It's the longest side.
It's the longest side. What else do we know about it?
C.
It's usually C when we cheat and write Pythagoras' theorem as a squared, b squared, c squared. Yes. It's across from the right angle. What do we know about the right angle? 90 degrees. What do we know about the other 2 angles in a 90-degree triangle?
They add up to C.
They have to add up to 90, so they're both smaller than 90, yeah? Can they both be the same length?
Yeah.
Yeah, they can both be 45s, right? Makes an isosceles triangle. Now, if 90 degrees is the biggest angle and it's across from the hypotenuse, look here. Does that share any characteristics with these triangles I've drawn here, which are not 90-degree triangles?
No.
Sure they do, Nadja. What is that thing that, what is the characteristic that they share? Yeah, 95 is the biggest angle, and it's still across from the longest side. We don't call it a hypotenuse anymore. Why? Because it's not a 90-degree angle. But it is still the biggest angle across from the biggest side. What's the smallest angle? What do you notice? It's across from the smallest side. What do you notice about the middle angle? It's across from the middle length. Everybody got that? Excellent. What else can you tell me about these 2 triangles? Parveen. The smaller one is enlarged to make the bigger one. I'll finish your sentence for you so that works. Yes, you're absolutely right. They share all 3 angles, don't they? Okay? Everybody with me there? All right. Now when you turn your page over, you will see a chart. Please fill that chart in while I finish writing your notes that will be on the video for you. Okay, I'm going to switch back to the fancy pants way of doing business here, to the computer screen, and ask you guys to fill these in for me. Angle A was 30. Let me get a good color going. 30. And angle D was 95. We'll just finish one. 55, 95. Side A, little a. What are its other two names? CB or BC. It was 4.5. B, little b, which was AC or CA, was 7.3. And little c was what? 9 straight up. And his name was either AB or BA. Do the same thing over here. Angle E was 55. Angle F was 30. Side D was 13.6. Side E was 11.8. And side F was 6.9. Yeah? Now when we compare them, these angles are all equal, yeah? Equal angles mean similar triangles. And similar triangles, I'm going to highlight the word similar because it is not the same. It has a symbol. It is this crooked equal sign. Okay? And that means that the triangles measurements or dimensions are related. And here's what I mean. What is the length of side A divided by side F? So I go to my line. Length of side A was 4.5. Length of side F was 6.9, yes? So when I bust out my calculator, I get what?
0.65.
Thank you. I didn't want to bother with it. 0.65, yeah? Everybody cool with that? Okay. Now what happens when I go B to E? 7.3 and 11.8. What do I get?
0.61.
0.61.
Or, 0.62.
Cool. Okay. And what do I get when I do the last one, which was 9 to 13.6? 0.66. Is everyone cool with that? All right. Now, what can you say about those three numbers?
They're all 0.6.
They're all very close together, aren't they? Right? What do you think would happen if we had exact measuring devices?
They'd all be the same.
They'd all be exactly the same. Of course they would. And this means that every triangle that shares those three angles will share that ratio, which is how we work out, how we are able to draw a blueprint of something and then build this school from it. Understand? Some of you, hopefully from grade 9, will remember this as when you get two triangles that look the same, and you know this is 6 and this is 12, what do you know about the other sides? That they're all doubled. So if this is 3, what's this side? 6. And if this is 4, what's this side? 8. You all remember this, yes? And you set it up like this. 6 over 12. You find any matching pair. And then that makes 3 over x and 8 over y. All of those fractions have to be the same. We all remember this from the 9th grade, yeah? If you don't remember it, you're learning it now.
Okay.
And we just proved it, yes? Everybody cool? Does it matter how the triangles look?
No.
No. If you are told two triangles are similar, then this must be true. Do you understand me? Okay, that's problem 1 that messes you guys up. You forget that if I draw them to look differently, you want them to be different. So that's number 1 mistake that kids make. The second mistake they make is this. You can draw this if you want on the bottom of your sheet. I would recommend it. Can you solve that? Right now, can you solve this? Why, Kobe? Okay, well, it was 50-50. You had a good shot, yeah? Way to gamble. Kobe says yes. Can anybody give Kobe the reason why he is correct? This is perfectly soluble.
Because you divide 6 and 1.5, and you multiply the other
6 and 1.5?
you 6 divided by 1.5 to get
You would use 6 and 1.5.
6 and 4.
6 and 4. Why 6 and 4?
Because they're the same.
Because they're the sides of the same. That's the other mistake, Supri. 6 is between this angle and the 2 dot angle. So I must compare it to the same side that is between that and the 2 dot angle. That's what they do in the provincial. They rotate them around. No, not because they're jerks, because the world doesn't set it up perfectly for you. Kind of like how when I do the warm-up every morning, it's not garbage, zodiacal symbol for male. It's garbage man. Right? It's never what's on the screen. So you got to be aware of that, right? And once you have that set up, does it matter which way you make the fraction? No. Can I compare 4 to 6? That's okay, right? I can also compare 6 to 4, can't I? But once I make that decision, what must I do? I'm going to call this triangle A and I'm going to call this triangle B. What must I do for all the rest of this? Keep it the same. So in this one, triangle A is in the numerator position, yes? So it would be 1.5 over what? Y. Between the 1 dot and the arc. Between the 1 dot and the arc. Okay? And the third one would be x over what? 5. And down here, we switch it around, 6 over 4, so it would be y over 1.5 and 5 over x. Everybody cool? And we all remember how to solve this, yes? Algebraically, 4 over 6 equals 1.5 over y. Algebraically, how do you solve everything that is fraction equals fraction? Cross multiply. So, algebraically speaking, we do 4y equals 6 times 1.5, which is 4y equals 9, which is y equals 4.5. Right? Algebraically. There's a shortcut. What's the shortcut? Multiply the pair, divide the spare. Okay? Every time you see fraction equals fraction, from now until the end of your math career, you can automatically do this move. Okay?
Yes.
This is what it is algebraically. This is the shortcut. So on your calculator, you would just go, and I like to do calculator key punches in red, 6.5, you don't need brackets, times 1.5 divided by 4 equals. And your calculator will give you the right answer. Is everyone cool with that? Yeah? Okay. Now, listen please. The second worksheet I gave you was on similar triangles, yes? I said if you could do it, go ahead. If not, we were going to work on it today, yeah? All right? Did anybody in their 3-day weekend do that, the last page? A couple of you did? Excellent. That gives you more time to work on your project, which is due Friday. If you did not get that project, you need to get it from me. Okay? Also, today we have your tests to go over. I'm going to spend a moment going over this test specifically because this test is traditionally not done as well as future tests because there are so many little tricks in it. Okay? So I'm going to give you back your tests and go over them as well. Everybody cool? Okay. So everybody has something to do, yes? Unless you were one of those people that did the similar triangle sheet and has their project done. Are there anybody that is in that boat? Good. So everybody has something to do. That makes me so happy. You do not need the rulers, nor do you need the protractors to do these worksheets. I do not think. The worksheets have all the angles written on them, yes? So you need not your protractors nor your rulers. So if you have one of my protractors or one of my rulers, please return it to me. If they came with a plastic sheath, please reinsert them into said plastic sheath and hand them to me. Or en français, donnez-moi. Donnez-moi. Parce que le français est une belle langue.
And I don't,
Even though all of you détestent le français.
I don't think I picked up the worksheet or the...
You probably didn't. Many people did not. Although I printed 30 copies and I did not have enough. So some